So now we are going to see the topic on arc voltage. So what is an arc voltage? So you know now what is an arc? Arc is the medium which is exists between the contacts, which is nothing but it's an electrical parameter which is exists between the contacts. So even though the contacts are opened, still there will be some contact, some voltage, some occurs between the contacts. This voltage is called as the arc voltage. So once the arc is produced, this voltage will come, and this voltage will appear only during the arcing period, and this remaining conditions, this arc voltage will not be there. You can see the third point. So it is a low except for the period that fault current is at or near the zero current period. So we are seeing this for the AC circuits. Already I have told. So AC circuit you will be having the both positive half cycles at one where when one half cycle completes, it will be coming back to the zero. So its value is low except for the period that fault current is at or near the zero current period. So it will be low at the zero current period, and the remaining period we will be having this arc voltage. So at current zero, the arc voltage will increase from the current zero. The arc voltage will increase and will reach even up to the peak value, and it will maintain a current. So it will maintain a current, and even though this contact is opened, there will be an existing of a contact will be there. So actually, the circuit breakers are used for production purposes. So even though the contacts are opened, even that's an excess of voltage or a current, then it is not efficiently working. Okay. So the voltage which exists at the contact during the arcing period, that voltage is called as the arc voltage. Next is recovery voltage. So after that zero point, so the normal frequency RMS voltage that appears across the contacts of the circuit breaker during completes the interruption of the arc. This is called as the recovery voltage. Now you can understand with this diagram. So you can see this diagram. So this is system voltage. This is normal sinusoidal voltage. You can take this is the normal sinusoidal voltage. This is the system voltage. So now if a fault occurs, the fault current. So you this is the fault current. So when the fault current is at zero, we saw the previous points. When it is at zero, this will be low. The arc voltage will be low. When the current is at zero, the arc voltage will be. After that instant, it will start increasing to the peak period. So this will be continuously, and then after that again it will come back to the normal sinusoidal voltage. So this highest peak range voltage is called as the restaking voltage, and after that it will recover and it again it comes back to the sinusoidal voltage, and it will complete one cycle. That it is called as this voltage which again comes back to the normal sinusoidal after the transient period. It's called as the recovery voltage. So what is the arc voltage? The voltage which exists between the arc is called as the arc voltage, and this will be at the instant of zero, this will be low. Then after that it will be start increasing to the period. This is called as the transient voltages also. This transient voltages will be appearing across the contacts for the few minutes. That is called as the restaking voltage. And this restaking voltage after a few minutes it will be recovering, and it again becomes a sinusoidal voltage. That is called as the recovery voltage. This is the difference between the arc voltage, restaking voltage, and the recovery voltage. So you can see what is the restaking voltage. So it is the transient voltage that appears across the contacts are at near the current zero during the arcing period. So it is a transient voltage that appearing across the contacts of the circuit breaker or near the current zero during the arcing period. So this voltage is called as the recovering voltage, the restaking voltage. So at the current zero, the high frequency transient voltage will be appearing across the contacts. So the same thing, what I have repeated, this is the points here. So why this restaking voltage happens is due to the distribution of energy between the magnetic and electric, because you can see that you will be having some more magnetic coils will be there. So the rapid distribution of energy between magnetic and electric fields, so with the plant and with the transmission lines, so that is the energy generating plants and the transmission lines of the system. So because of this rapid distribution of energy, these are transient restaking voltages of this. So this transient voltage is called a restaking voltage. So next, if the dielectric medium is more when compared to that of the restaking voltage, and then the restaking voltage, the arc will get reduced. So if the race-taking voltage value is greater than the dielectric strength of the medium, then it will be persisting for the another cycle also. So if the dielectric medium which is acting between the contacts is air. So if the dielectric medium strength is higher than that of this transient voltage, then the race-taking voltage will be, this arc will be reduced. If it is race-taking voltage value is higher than the dielectric medium, then it will be existing for the next half cycle also. Then you can go for this half cycle. Then again here also next half cycle also it will be repeated. So next concept which we are going to see is minimum oil circuit breakers. So as I told, depending upon the type of the medium which we are using for reducing the arc, according to that we are classifying the circuit breakers. So if we are using oil as a medium for quenching or reducing the arc between the contacts, then the circuit breaker is called as the oil circuit breaker. So in your topic they have given only the low oil circuit breaker, and it is also called as the minimum oil circuit breaker. So let me first show the diagram of this minimum oil circuit breaker. So in this minimum oil circuit breaker, you can see there are two compartments which is present. You can see this is the one compartment, and the lower one which is called as the lower compartment. So this compartment is called as the circuit breaking chamber, and this compartment is called as the supporting chamber. So we are having two chambers, so two compartments, and it's also called as two compartments. So this upper compartment you will be having the fixed contact, and another one moving contact also will be present with the upper chamber. And the third one, which is called as the top chamber, which contains the breathers and which contains the oil level indicators and gas ventilators. So these are the parts which will be present at the top chamber. So these two chambers are most important. Now you can see here the top chamber and the lower chamber are separated and will be separated. And what is the need of this partition is the arc which is produced will be reduced or removed, deionized with the help of this oil at the upper chamber. So once this arc is nothing but, you know, it is an electrical spark or something. So this oil, when it comes in contact with the arching period, this will be heated, and this heat will be absorbed by this oil and it will be lubricated, and this oil will be contaminated after the fuse operations. So this contaminated oil should not mix with the lower chamber. So for this, there is a partition between the lower chamber and the upper chamber. Okay. So then you can have here the lowest, you can have a one piston arrangement which is used for operating this moving contact. And if you want to remove this oil, you can drain the drain with the drain valve. We can remove this. So this is the operating rod. Okay. So this is the construction of this oil circuit breaker. So what is the advantage of this minimum oil circuit breaker is, here this in this circuit breaker only minimum of the oil will be used for, only 10% of this oil will be used for quenching this arc. Remaining oil will just be used for the insulation purpose. That is the advantage of this minimum oil circuit breaker. So these are the points which I have repeated here. So in the bulk oil circuit breakers, the oil has to perform two functions. So one is quenching, another one is for the insulation purposes. So in this minimum oil circuit breaker, the percentage of oil which is used for reducing this arc is very less. Okay. So what is the advantage of this is tank size and the weight of the breaker at firing. These are all can be reduced with the help of this minimum oil circuit breaker. Okay. So these arrangements, as I told, so the circuit breaker chamber requires only small amount of oil for arc extinction. The oil can be replaced. So these are the advantages of the separation. So as I told, the supporting chamber and the two chamber, three chambers are present. Top chamber, this supporting chamber, porcelain. It is made up of a porcelain and it will having the insulation material. Then the oil will be filled in it. So it is will be having the contacts. And so we'll be having an piston arrangement will be present at the supporting chamber. In the circuit breaking chamber, it is also made up of a porcelain chamber and it is filled with the oil, and it will be having the parts such as fixed and upper and lower fixed contacts and a movable contact and a turbulator. So in the top chamber, you can see you will be having the breather and you will be having the ventilating ducts and the oil indicators. Everything will be present at the top chamber. So when this expansion of oil happens, this breather for all these purposes will be done by the top. So how it operates is under the normal operating condition, this moving contacts will be engaged with the upper fixed contact. So at only when fault occurs, when the fault occurs only, the circuit breakers will be operating. So when the circuit breaker contacts gets operated, at the time only the arc will be produced. So when the arc is produced, the oil will be forced between this arc medium, and this oil will be operating with this high temperature arc which is between the contacts, and it will be ionized, and the gas will be produced, so with the high pressure. So and this oil will be moving contacts. With the help of this moving contact, will be passing through a hole in the moving contact and forcing the oil through the passage of turbulator. So this will process will be remaining process will be done at the top chamber, and now totally our arc is reduced. So what is the advantages? Only lesser quantity of oil is used. We don't want much amount of space when compared to that of the bulk oil circuit breakers. So risk of fire is very less. So maintenance is also very less. These are the advantages of this minimum oil circuit breaker. But also has some disadvantages. So the degree of carbonization will be increased. That is, since we are using only the minimum, we are using only the small quantity of oil. That's fine. Then when the oil gets lubricated, the gases will be evaporated. Gases evaporation, the gases will be formed, and it is a little bit difficulty in removing these gases from the space at the top chamber. And the dielectric strength of oil retardates ability with a higher degree of carbonization. When the strength of the arc is very high, so dielectric strength of the oil will be reduced easily. So oil has to be removed. So these are some disadvantages which exist here. Okay, so tomorrow we can see the air plus circuit breakers. Let us close with this. Okay, I think 30 minutes it is covered. More than that we cannot use here also. Okay.